Okay, so this is the honors titration worksheet. So the directions say to determine the concentration of acid or base, we can react with the opposite, base or acid, of known concentration until it is completely neutralized. The point of exact neutralization, known as the end point, is noted by the change in color of the indicator. So a lot of times we use phenolphthalein, but you can use other ones, of course. Those are on table N. We will use the We will use the following equation. So remember, we talked about how this is on the reference table. This and this we are including for the honors, because on the reagents, they're always going to make sure that the equivalences are the same. But that's not true in real life, so we need to account for that. So the hydrogen ion equivalence is this: molarity of acid, volume of acid equals molarity of base, volume of base, the hydroxide equivalence. So it's pretty straightforward algebra, and we just need to figure out these equivalences. Question 1, a 25 milliliter sample of HCl was titrated to the endpoint with 15 milliliters of 2 molar NaOH. What was the molarity of HCl? So first thing you need to identify is who is the acid and who is the base, because that's going to really affect things if we don't, keep them organized. So who is an acid? Well, you could check table K. Table K is the acid table, and then table L are the bases. So this HCl is an acid, and NaOH is the base. So that will help organize our thoughts. So the first thing we need to do is figure out equivalences. So HCl is here. Equivalences are how many protons are going to be given off, how many hydroxides will be given off. So let's break that down into its ions. It's going to be breaking down into H plus and Cl minus. So how many H's do you see? 1. So the equivalence is 1. Then you look over here to NaOH. NaOH, not equal sign, sorry, is going to break down into Na plus and OH minus. So there's only one OH, so the equivalence is 1 here also. So that's not going to adjust our math at all, but we should include it just because it's good practice. So there's my equivalences. Molarity of the acid, that's what I'm looking for. That's my variable, okay? Volume of the acid, 25 milliliters, okay? Molarity of the base, 2 molar. Volume of the base, 15 milliliters. Okay, so once again, the equivalences, which we already calculated, go here. And again, this is all multiplication, so they can be, you can say 1 times 25 times x, or 25 times x times 1. That doesn't matter. Equals 2 times 15 times the 1 here. All right, so you're going to get 25 times, let's just call it x, whatever. And then when you multiply these three things together, you get 30. Divide by 25. And again, I'm working with a mouse here, so I apologize. I bought one of those optical mice pens. Should be coming soon. So when you do that division, you get 1.2 molar. And that's the molarity of the acid. That's M sub A. So in this case, the equivalences did not matter. So our math didn't change. So in this example, we have 10 milliliter sample of H2SO4 exactly neutralized by 13.5 milliliters of 1.0 molar KOH. What is the molarity of H2SO4? So who is the acid? Who is the base? Whoops. Who is the acid? Who is the base? So base is this one, because I see hydroxide. So I'm just going to underline all of the base stuff in blue, and acid is going to be in red. So here's that. So 10 milliliters. That's all I've got. So it looks like I'm looking for the molarity of that. So once again, I'm looking for molarity of acid. So time for equivalences. H2SO4. Now you might already be able to see I've got 2 H's. It's going to give off 2 protons. Let's just prove it with H plus. 2 of those, excuse me. and sulfate minus, because if I asked you to this on a test, I would like to see all that. So what is our equivalence in this case? It's a 2. So let's set this up. My equivalence is 2. Molarity of the acid, I'm solving for it. Volume of the acid, 10 milliliters. Okay, so let's now talk about the base side. So we have KOH. You might already be able to tell what the equivalence is, but let's prove it. 1K, 1OH. How many hydroxides? 1. Equivalence would be 1. Molarity of the base is also 1. Volume of the base, 13.5. Okay, let's do some math. So we get 2 times 10, so that's going to be 20 times X equals 13.5. Divide both sides by 20. Notice I'm not being a real stickler about sig figs. If you were to talk sig figs, you'd say 3 here, 3 here, 2 here. Technically, we should have 2 sig figs in our final answer. So let's keep it as 0.68 molar. That would once again be molarity of the acid. Okay, so in this case, you notice there are twice the number of protons being given off versus the hydroxide. So that did affect our math. Number 3, how much of 1.5 molar NaOH is necessary to exactly neutralize 20 mils of 2 molar phosphoric acid? So I know this is phosphoric acid, so let's call it what it is. Molarity of the acid, volume of the acid. So let's take phosphoric acid. Again, you might see, okay, there's a 3 there. The equivalence will be 3. Just prove it. Show me. 3 H pluses and minus 3. So the equivalence of that would be a 3. So equivalence times molarity of the acid times volume of the acid equals. Now let's talk base. Base. There's the molarity of base. We don't know volume, but I do need to figure out equivalences. So again, you might just see it. If I ask you to prove it, you need to do it like this. So the equivalence of that is a 1. So there's my 1. My molarity of the base is 1.5 molar, and I don't know volume of the base. Okay, so I do my math, plug these into my calculator. I get 150 equals 1.5. Let's call it X, and then divide both sides by 1.5. 1.5. So X is going to be 100 milliliters. And that's the volume of the base. Sig figs, 2, 3, and 2. So you could say that to make it 2 sig figs. All right. Should be okay so far. I think once you set it up, the actual math shouldn't be too bad. But of course, that setting up is always important. How much 0.5 molar HNO3 is necessary to titrate 25 mils of 0.05? And I forgot that. Oops. Molar calcium hydroxide solution to the endpoint. So since I have blue, I'll look for bases first. This is a base. That's the molarity. Here's the volume. So let's talk about the equivalences for this calcium hydroxide. So calcium is a +2. What if you forgot that calcium is +2? Well, a couple ways you can remember. Crisscross that 2 back up, or go to periodic table and figure out the charge of calcium. And there are my hydroxides. There are 2 of them, which means the equivalence is a 2. So on the left, or excuse me, the right side, which doesn't have to be the right side because it's, multiplication, but just keep all the base information together. There's that. My molarity is 0.05 molar, and my volume is 25 milliliters. Now let's talk acids in red. So we have here, that's molarity. Again, we're looking for how much. So let's do equivalences. HNO3. That's going to be an H plus and an NO3 minus. So this means the equivalence is going to be a 1. So 1 times 0.5 times, I don't know the acid amount. I don't know the amount. So let's go ahead and let's do that math. So we have 0.5 times x equals 2 times 25 times 0.05, which gives us 2.5 divided by 0.5 on either side. X equals, now the answer is 5. Let's talk sig figs. Okay, that's 1 sig fig, so we can maintain 1 sig fig. Although I don't love 1 sig fig. Volume of your acid. How are we doing? Hopefully all right. Last one. What is the molarity of an NaOH solution if 15 milliliters is exactly neutralized by 7.5 milliliters of a 0.02 molar HC2H3O2 solution? Okay, so I have red right now, so let's talk acids. Who is the acid? Here it is. That's acetic acid. So there's my volume, there's my molarity, so I need to figure out my equivalence. Now this is tricky because I see 4 hydrogens. Is my equivalence going to be a 4? The answer is no. Why will it not be 4? Because what is this? This is a polyatomic. This is acetate. And acetate is etched in stone. You cannot change that formula. How it's going to break apart is you're going to have the H plus, this front part, and then you're going to have C2H3O2 stay together. So my equivalence is just 1. 1 times 0.02 times 7.5. There's my acid side. Okay, blue for base. NaOH, we are looking for the molarity, and we have the volume. So we need the equivalence. NaOH, we've used this several times before, but just, got the Na plus, OH minus. Our equivalence is 1. So we have 1 times molarity of the base, I don't know. Volume of the base is 15 milliliters. So go ahead and do your math. Multiply these 3 things together, you get 0.15 equals 15 times x, call it x. Get rid of that by dividing both sides by 15. Whoops, crossed off the wrong thingamabob. Oop. Okay. So get rid of it that side. So do your math and you're going to get 0.01. Let's make sure sig figs. Do we need 2 sig figs? No, 1 sig fig. This is 1 sig fig, so that's fine. This is going to be the molarity of the base. And so obviously we need the units. MB is fine. You just say 0.01 molar of the base. So again, the formula itself isn't that hard. For the regions, once again, they're always going to have the same equivalences on both sides, either 1 to 1 or 2 to 2. You don't even need to include that on the regions. In my class for the honors, I will ask for it because I will make sure they're not always a 1 to 1. So for example, number 4 was a 1 to 2, and this was a 3 to 1, and there was a 2 to 1. So be prepared. All right, folks, hope that helps. Take care.